So hi everybody and welcome back. This is C++ tutorial series for absolute beginners. This is video 339 and in this video we continue again with our move constructor and with the examples where I go a little bit in detail and will repeat again the whole thing what I learned so far in C++ when we see the code. And let's get started. Again, here in language, we click on language, then we go to the classes here in move constructor. And down to the examples, we already started to talk about this. You should have this in your IDE or use here the compiler explorer. And we have already talked about the first example here a little bit. We started it at least with this temporary unnamed object, and from there we continue. And now we want to talk how this object is created more in detail, which means we have to jump to the class or to the struct or the union, whatever this is. What we do there, first of all, we hover with the mouse over it to see what this part is. Most time, if you are using an IDE, for example Visual Studio, then there is a tooltip and you can already see it. And if this is not enough, just select the options, right click and jump to definition or declaration, and it jumps to the code where this one is created. In my case here in the compiler explorer, I have not this option, so I scroll just up and here on top we have it. So, and when we try to create an object, then the compiler is all time calling at first a constructor. Here in our struct A, we have provided constructors, not one, but many. One is the normal constructor, this one here, and the other is the copy constructor, and here we have the move constructor. Let's call, well, the compiler will call the normal constructor who is creating the object, and this is this one here. First question, what kind of constructor we have here? This is a custom constructor and not a default constructor. And second question, why is this important to know? Because there are different behaviors from the code if you provide a custom constructor or a default constructor. Sometimes, for example, if you're inheritant and you have provided a custom constructor, then you can do sometimes special things and sometimes not. And yeah, keep this in mind. Creating a default constructor and custom constructor have special behaviors sometimes, which we will repeat as well when we're there. So next question. Here we have a constructor, and you can see the constructor is all time starting here with the same type. Okay, but how you can distinguish these constructors, because they start all time with the same type, and then they have here the parameter list, right? I mean this parenthesis. And the answer is, I just said it, you can distinguish the constructors here with the parameter list actually. That's very important because the parameter list has a special order. For example, the normal constructor has no special order actually, but it can't start with a ampersand because this is the special order for a copy constructor that you can start here with this one, and you are probably going to use a copy of this object. And the same goes here for the move constructor. You can't start with a double ampersand in the parameter list because this is a hint that this one will be the move constructor. And we talked also about this parameter list. You can then use sometimes this, we will talk about this a little bit later, what this const doing and not const and so on. But right now, here on top in our constructor, you can add whatever you want for parameters. In this case, we have no parameters, which means the next part here is a little bit strange. What is the next part? First of all, here, this one. And this one is an initializer list. Okay, next question. What is an initializer list? Initializer list means just we are initializing member variables. Okay, and what are member variables here in this struct? Member variables are just variables which belongs to this struct. In this case, we have here the string s and int k. Okay, and what is this initializer doing again? It is initializing values to this members here. Okay, and what values it is initializing? Here we have test and -1. Okay, and what are this test and -1 here in this special case? These are default values. Why I say these are default values? The answer is because normally these values which are initialized here and here should come from the parameter list here, but we have here no parameters, so this struct here is constructed with default values which are set here and here. Another question, can we could we make this differently? The answer is probably yes. For example, I could skip the initializer list. That's possible. I could just Control X here, and instead of that I could just initialize this directly here with so, and then the same thing you would do here with with the other one. This one works too. You can see no here in Compiler Explorer, if there is no error here, it will show instantly if there is an error, but there is no error. But here we can do this too. And actually this one is not bad to do this here. If you have anyway no parameters here, and we don't have, then you should anyway initialize variables all time with a default value, because random access on memory should not happen. And that's why this style is not bad normally. But the initializer list, again, let's go here a little bit back to our start point, which was this one here. But the initializer list is the right way to initialize variables if you have one. So here they are initializing just default values. Okay, possible, but it's more a showcase, because normally this initializer list is taking, like I said, parameters from here, from the parenthesis from the constructor here, and then it's taking this one here, this variable here from here, and then assigning there. That's the normal way. Okay, one more step. Here we have a function body. For what we need that? Answer. The first case you can see here, we can use the function body for additional instructions. Here I have just see out, I want to see when this constructor is called, but in general you will see what many do is also initialize variables like we did here in the initializer list. Instead they are initializing it not here, they will initialize many variables here in the function body of the constructor. And this is also possible, almost all time possible, not all time. That's very important. It's not all time possible, but these are very rare cases. So you will see many are using just here the function body. And if you have any questions like all time, write in the comment section. See you in the next video where we continue this. Bye.